In this video, we'll talk about Bayes theorem. Bayes theorem is a really powerful and important term in probability and statistics that will help us find really intuitive probabilities. So to motivate the example, let's consider two events. We are a manufacturing firm and we supply our inputs from two different suppliers, and let's say that A1 is the event that the parts come from seller 1 or supplier 1, and A2 is the event that parts come from seller 2. Now these parts can be good or bad, and the table that we have here is giving us a distribution of those. But Bayes theorem helps us figure out, let's say we get a part that is bad. What is the probability that that part may have come from, let's say, firm 1? So we call A1 and A2 and the likelihood of these as prior probabilities. So let's say that we source 65% of our parts from firm 1. So the probability of us getting our supplies from firm 1 is 0.65. And let's say the probability of us getting our supplies from firm 2 are 0.35. From each of these, we can have two events. One event is that the part is good, and the second event is that the part is bad. So the first cell, the cell here, gives us a probability that we have got an event, a part from firm 1, and that part is bad. It's 0.98. Similarly, 0.02 is the probability that we got the part from firm 1 when the part is bad. And then 0.9, the probability that we got a part from firm 2 and the part is good, and 0.1, probability that we got the part from firm 2 and the part is bad. So we can start creating some conditional expectations. So if this thing here is essentially giving me probability, and again notice the way I write this, I'm going to say conditional on A1, that we got the part from A1 and that the part is good. That probability in the first cell here is 0.98. Similarly, the second cell gives us the probability. Again, notice I'm writing my conditional first, the fact that this part came from firm 1 and this part is bad, that's given by 0.02. Similarly, this cell gives us the probability that the part came from firm 2 and the part is good, and that is 0.9. And then the final cell gives us the probability that the part is bad, conditional on the part came from firm 2, and that's 0.1. So now we can kind of construct a path. We can look at the intersection of these two events. So what is the probability of a part coming from firm 1 and the part is good? That is given by the probability that the part came from firm 1 or PA1 times the conditional probability that the part is good and the part came from A1, which is essentially the probability of us getting our supply from A1 times what is the likelihood that the part is good given that it came from A1. And this is 0.65 times 0.98. And please check that that is indeed 0.637. Similarly, the intersection of A1 and B, that the part is bad and came from A1, is the probability of coming sourcing a supply from A1 times the conditional of bad given that it came from A1. And it's again 0.65 times 0.02, and which is equal to 0.013. Similarly, the second row gives us the probability of intersection of A2 and G. That's our first cell of the second row, first column of the second row. And this is probability that we got our part from stellar 2. And that part is good. Conditional and came from stellar 2, which is 0.35. The probability of us getting a part from stellar 2 times the conditional probability of getting a good part, given that it came from stellar 2, which is 0.9. And that is equal to 0.315. And then finally, the last cell gives us the probability that we got our part from A2 and that that part is bad. And that's given by probability of getting it from A2 times part being bad, conditional on the part came from our second supplier, which is 0.35 times 0.1, which is 0.035. So these are our 4 intersections. Bayes theorem will help us answer, suppose an event occurs. That event is that we get a bad part. What is the probability that that part came from either firm 1 or firm 2? Now, intuitively, we know that firm 1, we are sourcing 65% of our items from firm 1, and firm 1 seems to have relatively more better parts than parts that fail. We source fewer parts from firm 2, and firm 2 has a slightly higher percentage probability of getting a bad part. So somehow if we got a part which is bad, the probability of getting it from firm 2 should be a little higher than given that the part is bad and the part came from firm 1. Intuitively, we know that that makes sense, but the Bayes theorem will help us find these exact probabilities. And it is helpful to see the Bayes theorem in terms of a tree diagram as well. So I can kind of start my event. The first stream is that I get my part from A1. Then if I get my part from A1, the part could be good or the part could be bad. I could also get my part from my firm 2, and this part could be good, or this part could be bad. So the probability that we are on this stream, which was probability of getting a part from A1, we said is 0.65. Now, once the part is from firm 1 and the part is good, this arm gives us the probability of good conditional on A1, and this is 0.98. Similarly, this probability that the part is coming from A1 and the part is bad, so probability of part being bad conditional on coming from A1, this is 0.02. Similarly, the probability of getting a part which is good, given that it came from A2, we source 35% of our supplies from A2, and this probability is 0.9, whereas probability that the part is bad, conditional on that part came from A2 or firm 2, will be 0.1. So again, this stream, as you know, I just will write one intersection. This is intersection of A and G, and then we said this is equivalent to the probability of coming on path 1, and then here times getting a good part conditional on that part was sourced from A1, and this is 0.65 times 0.98, which we said was 0.637. And then this is PA1 conditional on bad, which is probability of getting it path 1 or part from firm 1 times probability of getting a bad part conditional on that part came from firm 1, which is 0.65 times 0.02, which is 0.013. My events are, what we are trying to calculate is parts being bad, what is likely to came from firm 1. So the other way the part could be bad is that the part could have come from firm 2, which is PA2 times PB conditional on A2, which is 0.35 times 0.1, which is 0.035. So a part that is bad could have been on this stream or on this stream, right? So our two events, or conditional events, are part being bad could have come from firm 1, so we could have been here. Part being bad could have come from firm 2, so we could have been here. So Bayes' theorem essentially tells us what is the probability that that part came from a particular firm, given that that part is bad. So Bayes' theorem is helping us answer this critical question. Given that the part is bad, what is the probability it came from, let's say, firm A? So this expression is called the posterior probability. It is because it is after the fact. Prior probability is a probability of getting a part from firm 1, probability of getting a part from firm 2. The posterior probability is the probability of an event happening, the part is bad. What is likelihood that that came from one of the two firms? So this essentially is given as the probability of getting a part that is bad and having come from firm 1 divided by all the likelihoods or cases where we could have gotten a bad part. So this is probability of A1 intersection B plus probability of A2 intersection B, that we could have gotten a bad part from firm 1, or we could have gotten a bad part from firm 2, and the denominator is acknowledging that. So the more common way in which we see then Bayes' theorem written down, again, it's essentially writing down our conditional probability formulas, which we had just written down here for the relevant streams in this formula. So we're interested in part coming from A1. So given that that part is bad, conditional on that part came from A1 divided by part coming from A1. Part is bad, conditional on A1, plus the part coming from A2 or firm 2 times the conditional probability of the part being bad and coming from A2. So in a nutshell, this is the theorem or statement of the Bayes theorem. It is giving us the posterior probability of a part being bad. What is likely that that part came from one of our two options. And these numbers we established, the first number is 0.013, probability that the part is bad, and that part came from the first firm, divided by 0.013 plus 0. Again, we calculated this probability as 0.035. Which is 0.013 divided by 0.048, and this is equal to 0.271. So Bayes theorem is giving us a probability that given that the part is bad, what is the likelihood of it coming from firm 1? We say the probability is 0.271. Now, notice that the complement of this event, the complement of, given that the part is bad, it came from A1, the complement of this event is given that the part is bad and it came from firm 2. So, which is essentially we are now swapping out 0.035 with 0.013. So it'll be 0.035 divided by 0.048, or we could have also done 1 minus this because it's a complement event, and we would have gotten 0.729. So and this makes intuitive sense as well. We had established that because we are getting more parts from firm 1, and firm 1 generally produces more good parts, fewer bad parts, we're getting less parts from firm 2, but firm 2 produces a higher percentage of bad parts. We would expect somehow that if we get a bad part, we might have gotten it from firm 2, more likely than getting it from firm 1. But there was no way that we could have ascertained those probabilities before. Bayes theorem helps us quantify those probabilities. So it helps us get these posterior probabilities. Given that the event happened, in this case B, the part being bad, what is the probability that that came from firm 1, which is this first option, or from firm 2, which is this second option. And we see that the odds are pretty heavily loaded that if it's a bad part, it most likely came from firm 2. And the probability of that is 0.729, whereas the probability of the part having been bad but having come from firm 1 is only 0.271. So hopefully this illustrates the idea of Bayes theorem and how it helps us calculate the posterior probabilities given the prior probabilities. And what is also cool about the Bayes theorem is that if at any stage these numbers change, so let's say firm 2 does a major overhaul of its technology, it's a new process in which its percentage of bad parts increases or decreases to maybe only 3%. Its good part goes up to 97%. We can very quickly run those numbers through this formula and then see the probability of getting a bad part. Given that the part is bad, what is the new likelihood that it came from firm 1 or firm 2? So it's a very easily adaptable method. But the idea is essentially figuring out what are the ways in which we could have gotten there in the denominator, and then the path to get to where we are in the numerator.